Hey guys, we're the Smart Serial Vending Machine team, and welcome to our presentation. My name is Long,
My name is Trent.
My name is Ben.
and so to start off with our presentation overview, we're going to go over the all the things that we're going to be covered today. So we're going to start off with team roles, background, project introduction, and then we'll move on to literature review, specifications, function overview, design and components, and we're going to show a video of our working prototype, and then we're going to finish off with challenges, results, and improvements, as well as our references. And for our team roles, I'm the team lead, and my responsibility was being the software lead, which involves developing the MicroPython program that runs basically our uh, design. And, and I will pass on to my team members for their responsibilities for the project.
And as my responsibilities for the electronics lead, I had to acquire all of our electrical equipment, and this included our motors, our actuators, sensors, basically all of the electrical hardware for our project. And I was also responsible for developing and drawing up a wiring circuit diagram so we could get a visual on how all of our different components were going to be wired together.
As for hardware lead, I was responsible for those preliminary drawings for our design, doing the CAD and 3D printing most of our parts, along with taking charge with assembly. So going into the background, our motivation behind our project was the coronavirus disease of 2019, or COVID-19. During the early stages, February 2020 to September 2021, there were approximately 146.6 million COVID-19 infections in the US alone. Vaccinations did become available in 2021. However, the appearance of new COVID variants are a current and ongoing concern. And during these stages, the emergence of contactless interactions emerged. These were to reduce physical interaction between individuals, reduce the spread, and they were a preventive measure. To introduce our project, we developed a smart serial vending machine. It requires only two user inputs. First is serial selection via a button press on the microcontroller. Second is bowl placement. After that, the device detects the presence of an empty bowl and dispenses a single serving of cereal. And it stops dispensing when either conditions are met, which is a single serving has been dispensed, or B, the bowl is at max capacity and risks overflowing. In comparison to our smart cereal dispenser, there are manual dispensers, which are the most common product. They're commonplace at hotels and resorts, specifically for those complimentary guest breakfasts. And the advantage of these are that they're relatively inexpensive and they rely on a simple mechanism. Disadvantages, they lack a dispensing system regulation. So cereal can just pour out on many of these models. And there's excessive physical contact with the controls, which is something we don't want when considering viruses and the spread of infection. There are also these smart cereal vending machines or automatic dispensers, typically used for grains, cereals, small objects. So these are pretty uncommon. There's few existing products, so the market is not as competitive. But in terms of advantages, they have minimal physical contact. They prevent food waste because they regulate how much is dispensed, and it's a smart system, so it can be tailored to suit the user's preferences. And in terms of disadvantages, the primary one is higher cost for those additional components. And I'm going to pass things off to Trent to talk about specifications.
Thanks, Ben. So, to accomplish our goals that we set for our project, we basically had to adhere to certain functional specifications. So These involved the entire unit weight being empty to not exceed 10 pounds. We set this to enable the unit to be moved from location to location easily and efficiently. The cereal carousel had to hold 3 types of cereal. This would enable the user to have more flexibility and more choices of cereal. And the entire product had to fit within a 2 cubic foot volume. This we chose because it would allow for a compact unit that would be able to fit in smaller spaces in your house or in a hotel or a resort on the breakfast table. And the required components that we chose to accomplish these were our Raspberry Pi Pico microcontroller with the RP2040 baseboard that it was connected to. We decided on 2 actuators, one being a servo motor, which would operate the gate to dispense a cereal, and a stepper motor, which would be responsible for rotating the carousel accurately per the certain amount of steps that we would determine, and they would align it over the dispensing hole. Our 2 sensors for the project included a load cell, which was responsible for measuring the voltage change due to the mass change of the cereal, and a photoresistor which would detect the presence of the bowl itself on the base plate. And finally, we had a display. It was an LCD screen which would prompt the user to select the 3 different types of cereal. In these cases, we chose Cheerios, Cinnamon Toast Crunch, and Frosted Flakes. And it would also prompt it to go to the next cycle. And moving on to the function overview, a cycle would first start when a user presses a button on the microcontroller to select one of those 3 cereals. This would prompt the stepper motor to spin this carousel and align the selected cereal hole with the depository chute. The user would then place an empty bowl on the designated bowl plate, which would cover the photoresistor. The photoresistor would detect that change in light since the bowl would be completely covering it, and it would prompt the servo motor to actuate and open the carousel gate. 1 serving of cereal would then deposit into the bowl, and as the cereal would be dispensing, the load cell would be constantly measuring the voltage change. And once that voltage changed reached a certain threshold, it would signal the servo to rotate back to its initial position and stop cereal from flowing. And once that bowl was full from that, the process would end and the carousel would rotate back to its initial position, and the LCD screen would reset to its initial prompt of selection, and the process would start all over again. So moving on to our designs and components that we used to construct our dispenser. Here we have our catted models. On the left-hand figure, you have the overall model that is designed in SolidWorks, and everything was assembled and calibrated and per certain measurements in our program. And here, our first component to mention is the carousel itself. As you can see in this upper figure, on the 3D printer that we used to fabricate it, we have our servo, which isn't quite visible in the model, but here's our physical servo with the actuator gate installed. And our final picture here is our base plate on the bottom figure here, and it was designed to be installed onto the load cell via 2 screws and a recess that allowed the photoresistor to be installed flush with the top surface of the plate itself. And here are our physical prototypes based off of those drawings and models. We had a few issues with fabricating our initial base, which will be covered later on. But to remedy that issue and overcome it, we decided to fabricate our base using cardboard and foam. It was not um, our expected outcome, but it did the job in serving as a mock-up of what our actual base would function as. And as you can see in the center picture, this is with the system fully assembled with every hole drilled, and this included the hole for the carousel itself. As you can see, it is attached and it has a serial load ready to dispense. And as you can see on the right picture here, there's a front view of the completed unit, including the LCD screen, the plate, the serial bowl, the chute itself, the stepper motor behind the chute, and of course our carousel with the serial loaded up and ready to dispense. Moving on to the electrical side of our project, here is our electrical diagram that was created using KiCad. As you can see here, the main components of the system were the Pico with our RP2040, a D-Rock power supply, the OLED, the load cell, and the HX711, and the motor driver with the stepper motor itself, and the photoresistor and its accompanying resistor. And it's also important to mention here that all of the components on the right-hand side of the diagram were basic circuits that were required from different labs throughout the 106 class. This enabled us to wire up systems simply and allowed us to get our system up and running quicker, and this allowed us to get a better system overall. So with that, I will hand it over to Long, who will be discussing the code of a project.
Thanks, Trent. So moving on to our code, as mentioned previously, so to start off, we have each of the 3 buttons on the Pico uh, assigned to a different pin. So from pin 20 to 22, as you see on the left side, and that will be our user input, so, or the command that will initiate the sequence of our code. And so once one of the 3 buttons is pressed, it will then go on to the various functions that were created for the stepper motor. So for example, each of the 3 buttons is assigned for a stepper motor to rotate, to take a certain amount of steps, as you can see on the screen right now. And that it will determine that the amount of steps that the stepper motor will take is determined by the rotation that it takes for the carousel to rotate to the right position, where the serial will be able to go downstream through the chute. And so once the button is pressed, the carousel will rotate to a certain amount of steps, and then it will move on to the next step, which is the servo gate, and that is operated by the photo sensor, which is essentially detecting the bowl placement. So once it detects the bowl that is in place, the servo gate will open, and then the serial will be able to go downstream, and then afterwards, the load cell will take over the control where it will detect the weight of the bowl, depending on how much cereal that's currently in the bowl. And then once it reaches a certain amount, it will then close the servo gate, and then the servo motor will rotate the carousel in a reverse direction into back to its original position, and that will finish off the sequence, and then it will cycle back to its initial phase, which is essentially asking the user to either press one of the three buttons again for dispensing its cereal, or simply just shut off and for the next use. And with that, here's our video of our working prototype. And with that, I will pass it on to Ben, who will cover our challenges.
Here we're looking at our challenges for our project. First, we had a few issues with our 3D printed parts. If you look at the figure in the top right, that's our carousel being printed. This was printed at 40% infill density. And this unfortunately had a large impact on the weight of the carousel. When we attached the carousel to our stepper motor and we ran the program, it had some issues with turning. It would skip some steps and it wouldn't quite reset to the same position every time. So it messed up, it affected our consistency and repeatability of testing. The weight also increased friction with the top of the base, and this caused some issues with rotation. If you actually look at the bottom two images, that is the base being printed, and this print unfortunately failed due to some filament feeding issues. So we weren't able to have this for the physical demo and for our prototype because of this. And we were forced to create the base out of cardboard and foam. So in the previous images, you saw the makeshift base. The tolerances on this were not perfect, so cereal would often fall between the carousel and the base, causing a jam, and it would impede rotation of the carousel. Furthermore, we worked with a load cell, and we had minimal experience running it with Python. We had some experience prior to this course in ME120 experimental methods, where we ran it with LabVIEW, and we used LabVIEW to record data. However, with our combined knowledge using Python, we had some issues with that, and also implementing the load cell code with the rest of the combined program. Moving on, we have, next slide. Moving on, we have our results and improvements. At the end of the project, we successfully assembled a functioning prototype, and our product dispenses cereal into a bowl using minimal user inputs. For future work or just improvements, we'd like to look at repeatability of carousel movement, essentially looking at how we can make it more consistent, examining the dispenser base, finished fabrication of a 3D printed one to match those tolerances, also accounting for different types of bowls, as we only used a paper bowl to test it. Things like plastic bowls, metal bowls, or ceramic bowls may affect how it runs. And also testing with different types of cereal. We only use 3 types. However, there are some different types of cereal that may pose some issues based on the geometry or the kind of powder or sugar that's associated with it. And moving on to the conclusion. So we utilized knowledge gained from all of our 106 labs to finish this project. We combined multiple sensors and actuators and wrote a program that operates each of them simultaneously. And we built on the knowledge of MicroPython as a coding language. We gained experience with fabrication using 3D printers and learned how to optimize our print settings in the slicer to get the parts that we wanted. We also learned how to use a basic circuit design software. In this case, we use KiCad to create our circuit diagrams. And we understood the importance of motor sizing per application as we were looking for components to put our project together. We looked at the torque required and the size of our components that we wanted to work with. And here we have our references. And thank you for listening to our presentation.